look at shapes of things that break the octet rule, meaning they're going to have more than 8 electrons around them. So this can happen. It happens because atoms can access their d orbitals, and so they can have more than just the 2 electrons in the s and the 6 electrons in the p. They can have more than 8 electrons around them. They can access the d's. And if there are 5 things around, 5 things repelling around this atom, well, if I have 5 atoms, there's going to be 5 bonds, so that's 10 electrons. Anything with 5 sticking out from it is going to have the basic shape of, it is called Trigonal Bipyramidal. So if you can see the triangle looking right here, so this is a triangle looking from here to here to here. That is a triangle, and if I can imagine, just like the pyramidal molecule, if there's a face here, and a face here, this would be a pyramid on the top, and there's a pyramid on the bottom. So this is trigonal bi for 2 pyramidal. So trigonal bipyramidal. Anytime you have 5 things attached, you're going to have a trigonal bipyramidal shape. It might be there's 5 atoms and we call it trigonal bipyramidal, or there could be 4 atoms, and then I'll pretend like this is the lone pair. So you can just pretend all you can see is the marker caps and not the actual marker. This lone pair would still be here repelling the other pairs to create this shape, but you wouldn't be able to see this, so it would end up looking like this guy. So you can see it's the same thing, it's just that we can see the lone pair on this one and not on this. And we'll get to the shape in a second. So whenever there's 5 things, imagine that trigonal bipyramidal shape, and then try to imagine what would it look like if you could erase one of those things. It's like a tetrahedral, but it's distorted. What would it look like if you can erase 2 of those things? Ah, it looks like the letter T. What if I erased 3 of those things? I need another hand. And I can just see there's this one line that's going to be left. It's linear. So instead of trying to memorize all of the shapes, really get a good handle of trigonal bipyramidal, and then imagine taking one thing off at a time. If you noticed, I didn't take anything off from the straight line. I took it off from the triangle. And the reason is there's the lone pairs. So if I don't have an atom here, I have a lone pair. Lone pairs spread out. They take up more space. And this atom is 90 degrees away from 2 others. So it has more space than these guys on the straight line part, because they're 90 degrees away from 3 atoms. So there's more space around the triangle for those big lone pairs. Okay, so if I have 5 things, I'm using an s orbital, I'm using all 3 of the p orbitals, and then I'm using 1d. So sp3d hybridization. We'll draw some so you can see why. 5 atoms, 0 lone pairs. So the basic shape is, I've got this central atom. It's got an atom directly above, 1 atom directly below. 1 atom is going to be in the plane, and then 1 atom is going to come out at us, big fat line. 1 atom is going into the board. Okay, so there's these 5 things, and we call this trigonal bipyramidal. Okay, because there's that triangle is right here, right? There's the triangle, and the pyramid is, like, you're not going to be able to recognize much of this, but there's my pyramid. Ah, okay. It looks like that. So here's Phosphorus Pentachloride. I've got phosphorus. It has 5 valence electrons, and I can see it's making 5 bonds. I'm going to spread those 5 valence electrons out. 1, 2, 3, 4, 5. And then at every valence electron, I'm going to put on 1 fluorine. And fluorine brings with it 7 electrons. So I'll put those on. 2, 4, 6, 7, 2, 4, 6, 7, 2, 4, 6, 7, 2, 4, 6, 7. Okay. Whoops. So there's my trigonal bipyramidal, the 5 atoms being repelled from the center. This guy is nonpolar because it's actually symmetrical. If you could see that, just going to put it back together. The triangle is a trigonal planar, and then this line is a linear. So you've got a nonpolar molecule basically stacked inside of another nonpolar molecule, so they all cancel each other out. Nonpolar things are symmetrical, so any negative here is bounced by negative on the other side. So, nonpolar. Let's look at another thing that has 5 things being attached. And again, if there's 5 things being attached, I know there's going to be 1 s orbital, all 3 p's, and the 1d. So this thing is also going to be s, oops, s, sp3d hybridized. So this time I'm going to have 4 atoms and 1 lone pair. So for this guy, I do that same trigonal bipyramidal structure, right? It's the exact same thing I drew before, right? But now instead of atoms, or all 5 atoms, I'm going to go atom, atom, because these guys have the least amount of space. So I need to put the atoms there. Atom, atom. I'm going to throw a lone pair right here. Okay, because this triangle has more space. So what this would look like is I can't see this. I've got 4 things, and they're almost like the tetrahedral, but it's the tetrahedral with this lone pair squishing the other atoms together. So it's a distorted tetrahedral, or tetrahedron. Tetrahedron. Okay, or you can also call it seesaw, which I like. I like seesaw, because it looks kind of like a seesaw. You can see the seesaw. Yay. Okay. I forgot to go over bond angles, but I bet you can guess them because we said that the triangle part is just like trigonal planar. So 360 divided by 3. So you're going to have 120, 120, 120 all the way around the triangle. And then the other part is linear. And you can see this linear has these guys at a right angle to it. So 90, 90, 90. So on the trigonal bipyramidal, all the angles were 120 around the triangle, 90 around the line. In your seesaw, where I can't see this electron pair that's right here, you're still going to have this 180, right? Pretty much 180, except the lone pair is going to repel this a little bit. So this thing right here would be a little bit more than 180. On this side, it would be a little less than 180 because this lone pair would be repelling. And then for this guy, we used to have 1, 2, 3, so it was 360 divided by 3, 120. But now I'm going to have a lone pair pushing these guys together a little bit more. So this bond angle will be a little less than 120. I want to write that down. So this guy is right here. It's going to be less than 90. And then from here to here, I'm going to put it's less than 120. Okay, and for the trigonal bipyramidal, it's just 90 to 120. So let's draw one. I've got sulfur tetrafluoride. Sulfur has 6 valence electrons, and I can see it needs to make 4 bonds. So I'm going to leave 4 electrons really far spread out. 1, 2, 3, 4. And then I've got one other lone pair. So 5, 6. There. So there's sulfur's 6 valence electrons. I'll put on the fluorines, 1 at each of these electrons that I left for bonding, and then I'll add the 7 remaining electrons for each fluorine. Okay, so then I've got sulfur tetrafluoride. And there's one more thing that has just 5. Well, 2 things. Okay, we're going to look at that same trigonal, or the trigonal bipyramidal, but this time around the shape we're going to have 3 of the things will be atoms and 2 are going to be lone pairs. So 5 things, still sp3d hybridized. sp3d. I start with that same shape, so atom in the center, atom above, atom below, 1 atom sticking out here, a red, then the 2 lone pairs, I'll have 1 coming out and 1 going back. Same exact shape, so this is still going to be a little less than 90. And this right here is still going to be less than 120 because of that repulsion. And you can kind of see what the shape looks like, right? I'll take this guy. I said first I put a lone pair here on that triangle, and then I put a lone pair here. So you can see, since you can't see the lone pairs, it looks like the letter T. Thus, it is named T-shaped. Yay! Thank you for making something that made sense and was easy for us. Okay, so it's T-shaped, and let's go ahead and draw one. I've got bromine. Bromine has 7 valence electrons. It usually makes 1 bond. I already know that this is going to violate that octet rule because it's going to make 3 bonds. So I'm going to separate the 7 electrons, leaving 3 available for bonding, and just because I already know what the shape looks like, I'm going to set it up to look like a T. And then, so 1, 2, 3, 4, 5, 6, 7. Okay. And then there's going to be the 3 fluorines. And now you can see it's the T, T-shaped. T-shaped, if these three things are the same, you can see that it's not symmetrical because you've got this negative area and no negative area up here. So this guy is going to be polar. Clearly I haven't really been adjusting all the polar, non-polar. Trigonal pyramidal is symmetrical. We said that because of the triangle and the line. So this guy was non-polar, but as soon as you take away one of those atoms right here, then if this is a negative fluorine, it needs to be canceled out by a negative fluorine on this side. So the distorted tetrahedron slash seesaw is going to be polar. So tetrahedron or distorted tetrahedron polar, T-shaped polar, they're not symmetrical. Then the next guy, still 5 things, but now we'll only have 2 atoms and then 3 lone pairs. So of course, if there's 5 things, one of those 5s will be an S, 3 of the 5 will be P, and 1 of the 5 will be D. So there's 5 orbitals being involved. It's the same exact shape. So got that center atom attached to 2 other atoms, and then the lone pairs go where there's the most space. So lone pair, lone pair, lone pair. So you can see that is a straight line, and the bond angle is a straight line. So it's 180 degrees. Those lone pairs are going to repel each other equally now. So this is just 180, and we can call that linear because it is. And the example, I have Xenon. Right away we know we broke the octet rule because Xenon has 8 valence electrons. It usually doesn't make any bonds. It can with this fluorine though. Fluorine is really electronegative, and Xenon is this huge atom. Fluorine's going to kind of attract the electrons that are on the outermost shell for Xenon. So I'm going to make 2 bonds by just leaving an electron here and an electron there. That's 2 of the 8. So 2, 3, 4, 5, 6, 7, 8. And now I'll put on my fluorines. And 1 more. So that's that. So now we've seen everything that can have 5. Let's look at everything that can have 6. Okay, so you can probably guess 6 things. 1 of those things is going to be an S. 3 will be P's. And I'm going to stop and start another movie.